All right, I think we're going to move right on through here. Looks like the next one is the clustered SCSI target using RBD status. I think this was Mike Christie's. Mike, this was yours, right?
Yeah.
Cool. All right. Well, take it away.
So this is a continuation of the one I did in Hammer. So I'll just start with like a status update. There was like 5 things that we were trying to complete, or 5 items that I needed to complete to be able to support running LIO on multiple targets and being able to access some export RBD devices to them. And so some of the stuff that I've gotten done or it's set is for configuration and distributing the device state. It looks like we're going to go with pacemaker. And so it's just a matter of finishing up modifying the existing iSCSI target and SCSI target and device resource agents. And those currently support active passive based on like this virtual IP type of failover. And so it's really simple to just modify them to support active for us. And with that, you can use like the pacemaker commands to set up the targets and the devices, or you can use various HA management GUIs that the distros have. I'm also working with the lib storage management people to modify their library and plugin and their tool to be able to create targets. And basically our plugin would just call those PCS commands so people don't have to do it directly. And that's pretty simple. The part we're working on, or that's more complicated, is being able to create their concept of pools out of RBD devices. And so that's just more details that we have to hammer out. Because I guess in order to do it generically across like a NetApp target and those other ones, it's kind of weird. And so those 2 items are pretty much done and set. The next one was for persistent group reservations. Originally, I was looking at using just DLM and CoralSync to provide locking across the cluster and protecting this PGR metadata, which basically just holds like the initiator information and IT Nexus information and what type of reservation it is and stuff like that. And since the last talk, I have implemented kernel RBD locking. So it's basically what we have in librados and user space right now, only it's based on the kernel libceph stuff, and you can make those calls from the kernel now. And the second part of that is being able to store the metadata that I need. I'm currently doing it, storing it in the RBD header. So I just added a new call into that class, cls_rbd.cc file. And that one, I'm going to send a patch for that soon for RFC, because I'm not sure. It's kind of the new call. I called it like set SCSI PR info, because I wasn't sure if I should do it like more generically or just they forget it and like I'm just gonna store like this exact data structure. So I need comments on that to see how people want to handle that. And that one I'll post soon. And then the next item was compare and write support, and so that's needed by ESX for its atomic test and set command, which is needed for their VAAI feature. And for that one, it's pretty much set. I'm just waiting for some other upstream people that need similar functionality to lay down this other infrastructure, so I don't have to do it because I have all this other stuff to do. But I get done with my stuff first, and I'll lay down that infrastructure. But right now, I'm just hoping that they'll need it sooner than me and implement it. So that's just like adding a bunch of fields and bringing up these fields and going through all the block drivers and doing it. And so it's like a upstream chicken, I guess we're playing. And so the big one that needs to be done still is the SCSI task management and like the unit attention and those type of handling. And for that one, I haven't worked on it at all. There's been lots of bug reports on the list about commands timing out and the error handlers failing. And so for that one, I've just been looking into originally we were just going to handle, or what happens now when LIO gets an abort from the initiator, an abort task management, is it just waits and hopes that the underlying device completes it in time before like the initiator task management abort timeout occurs. And for that one, I want to do something a little bit more intelligent and at least try to narrow down where it's hung and log a message, because it's really been difficult to debug that on the list, and it seems to be happening a lot. But yeah, for the most part, I don't think we can do a lot to really, if the command's like on the device, then we can't really unjam it. And so at least log a message. If it's jammed somewhere else, then I haven't been able to, I still need to look into more how to, unjam it in the stuff, like in the OSD layer or something like that. I don't really know yet.
Yeah. How long are those timeouts typically before things start to break?
So when the initiator sends a command, it'll normally be around 30 seconds to a minute. If that command isn't complete with that time, it sends the abort task. The abort task timeouts is anywhere from like 5 to 30 seconds to a minute again. It just depends on the operating system and how the person configured it. So,
okay.
And then after that, there's like,
Okay.
And so for the big one for that is still handling like the abort and how to do device resets. And for device reset, you want to kill all of the commands on that are running on the RBD device. Again, for that one, LIO currently, it'll just wait for all those commands to complete. And so there's not a lot it can do in a lot of cases, like, And then for if those fail, then it'll go to like a higher level error recovery. For like iSCSI, it'll go to like, it'll log out the session. And again, for that to log back in, and it waits for the commands to complete. So I need to look into some way to be able to actually do something to unjam these commands or something like that to make progress, or we're just stuck. And that's what we're seeing a lot of.
So we had a conversation several weeks ago where you were basically saying that the OSD failure detection timeout is like 20 seconds, and so it's not that uncommon to get an IO that will take that 30 seconds. And if you do trigger that timeout, then in general you would normally like start fencing and doing all that stuff.
Yeah.
Which, if overall the subcluster is just gone away for a minute, then is sort of wasted effort. I wonder if it makes sense to have an out-of-band communication between the LIO, the gateways or whatever, just for that reason, right?
Yeah.
Because I mean, if both the gateways actually haven't failed and it's actually Ceph that's going slow, then doing a failover between them is like is pointless. So if they could like coordinate so that they don't don't try to fence each other and go do nuclear, I guess.
Yes, because he has like this command called a query task.
Oops.
Oh.
Sorry.
There's a query task that's a newer SCSI specs. I don't know if we could. No initiator sends it, but if like LIO could do, or the block layer, the Linux layer, Linux could like query what's going on with this task to the Rattles or OSDs or something, it would be helpful. Or anything to tell us like, to prevent like failing over from doing anything to prevent the upper layers from doing their higher level error recovery, because that's a lot harder. Like for Oracle, it's really heavy and stuff like that.
Or even if they are doing that failover, then if the gateways can recognize that actually the gateways are fine and they're still both alive and cooperating and fencing isn't necessary, then they can do sort of a lightweight handoff between them.
Yeah.
So they can do a graceful lock break or whatever.
Assuming you're using pacemaker, you can store extra metadata within pacemaker. That's more than just it's up and running. So you could potentially have your resource script store that extra information, act on that information as part of its failover logic.
Yeah, I can do that. So on each LIO node, I can detect if like the other iSCSI gateways you can detect like if the service is running, and in like the monitor callouts, you can do various checks to see if like the iSCSI layer or the SCSI layer is running and things like that. And you could even do checks like I saw that there's like this code for the libceph and stuff. So like from the pacemaker user space monitor could act. It can do anything basically. It could do any type of RBD command to call into the actual RBD device on each LIO node to try to detect if that layer is gone or something like that.
They can send messages to each other through RBD. So it could be that, it might be that in most cases where you have a hung IO, it's like, it's not the entire Rados cluster, it's a subset of them, and it's probably not the one object that they're sending notifies to each other on. And so if they can send a notify to each other and do like a request lock break, and they get an ACK and says, okay, I'm increasing whatever, like so that even if like the normal reset procedure is cooperative and sort of skips the fencing part.
Okay.
Is that what it does now? Jason and Josh, I can't remember.
The lock break. It
Yeah.
It tries to, for the exclusive lock, it tries to be cooperative. It says, hey, please send me the lock.
Okay.
And if it fails, then it goes
Okay.
and says, well, let me go see if it's actually listed as a watcher. And then if it's not listed as a watcher,
And then
it
it
does
does
the break lock and blacklisting.
Got it. Okay. So in that case, as long as the kernel RBD is actually going through that whole protocol for lock break, then handling a reset in like the standard way where we just break the lock, take the lock, it'll cooperate and do it.
Okay.
And so that actually might give us 90% of the way there.
Okay.
Would that be okay with this if there are high IOs though on the original one?
What was that part?
Would that be okay to request that, like, transfer that lock cooperatively without blacklisting if there are like IOs in flight still on the original target?
I suppose technically not, but in reality, the client is going to send those same IOs anyway, right?
Yes.
Okay, so it's going to go ahead and retry on the secondary once it's failover anyway. So yeah, I guess.
But they might arrive out of order. Like it might write A, fail, and then write A, B to the same block, and then the original A gets there. So that might not.
For SCSI and ordering, for what we support now, it'll be okay if it gets reordered on that type of sequence. We rely on like the upper layers to like synchronize it correctly. And so like there's different type of ordering that people could set for at the SCSI level, but no one does it that I know of, I think.
I mean, it'd be a pretty extreme corner case, but it might be that we need to make a way for a live client to like explicitly cancel requests or something.
Yeah, but any kind of cancellation request is going to be racy because it could be all the way down to the drive already. Like, no matter where
yeah, but it could like say, yes, I successfully canceled it, or I don't know if I canceled it.
If it's down at the actual device, I was just gonna say if it's down at the device and it's hung because of that, then we're screwed no matter what we do. So it's okay if to like just wait or not do anything or just fail, because if it's hung at the device, it doesn't matter what path or what node we access it from, we're gonna be stuck.
Yeah, but I mean, there are a lot of cases where
communication issues with the OSD.
I mean, it's so think of one Rados client. It's going to say it has 10 IOs in flight or whatever. There are lots of different cases where we can conclusively know that we canceled it successfully. Like, for example, if we haven't sent it anywhere yet because the OSD is already down, then obviously we just take it out of our queue. We never send it. Or if we do have it outstanding to an OSD, then we can just maybe we can send a cancellation or something. Yeah, I don't know. Anyway, I guess this is we're going down the rabbit hole, but.
Sounds like in general right now, since no one uses those ordering guarantees on SCSI, we can just do the cooperative lock transfer and not worry about the in-flight requests. They're being resent to the secretary anyway.
With very high probability, I think, yes. Yeah. Okay.
I'll look into those things then.
I'm pretty sure I've asked this like 5 different times, but I always forget what the answer is. For the compare and write, that's the upstream chicken you're talking about is basically plumbing that through the block layer down to the driver.
Yeah, it'll be exactly like how. I was just saying it's exactly how unmap and trim is.
Okay. So when it actually hits RBD, then we'll send a special request to the OSD that will atomically do it at the. Okay, cool.
Yeah, I was looking into adding a new Ceph command to it, just like how it's limited with trim and stuff.
Perfect. Okay. Sounds great. Okay. Sounds good. And
that's all I really had.
Yeah. Okay.
I've been bugging you guys like every morning.
Yeah. Are there any questions for anybody?
Oh, I had one question for distributing my PGR metadata. So I just did that. I was adding that new class RBD command, and it's really easy to just set the data. But I wanted to be able to cache that data on each LIO node, so I don't have to go back and read it every time someone does a command. And so like people can do a watch on that object and be notified. But I was looking for a way to, like, before I was using CoralSync, and you could run like a command on all the nodes and be notified when that command is completed. And so I just wanted a notification that everyone has updated their cache. So like on node 1, I'll set the metadata, and then other people will be watching and they'll be notified and they'll update their cache. But I wanted to be able to be notified that they updated their cache, so I can tell the initiator that we're all set across the cluster. Is there such a thing in Ceph right now?
So when you send that notification, if you'll basically get a timeout if not everyone that's watching that file acts it in time.
Oh, okay.
And you can also even go above and beyond that if you want. If you had additional metadata somewhere else saying, here are the guys I know that I'm supposed to be watching for, you can watch. As part of that notification response, they can send whatever they want back and say, well, this is I'm client XYZ and I have successfully flushed my cache or whatever.
Cool. That's exactly what I was looking for. I'll look in the code some more. Thanks. That's all I had then.
Jason, is this something that is? I mean, this is sort of what the lock leader or whatever would do, right? So I mean, in the old pattern, you would set it on the object and then you would set a notify, and then only when that completes would you know that everyone has seen it. But in the new world, you actually just send a message to the leader and you let them do all that. Would this fall in that category, or?
I mean, all the new stuff. It's still everyone's watching the RBD header in the case of the stuff I'm doing. So everyone's getting all the notifications. It's just they say I'm not the leader, so I'm just going to ignore it. And by ignore it, they just send back a notify ACK, just so that you know if it timed out or not. And if it does time out, but in the cases where you're actually looking for a leader, even if it does time out, I say, well, I got a response from leader, and that's all I really cared about anyway. So I kind of clear out. I ignore the timeout error code that comes back from watch notify. I say, I got my response I was looking for from the leader. I'm good to go with whatever the leader said was the real status as part of his notify ACK.
So in practice, the person who's actually setting this SCSI reservation is probably going to be the leader, right? Like they will have already taken the exclusive lock and they will just.
Yes.
Okay.
With the new like leadership's framework that like Jason's written, it also has like different commands that you could do at so it could be like one of the commands would be reread their persistent reservation metadata and then send me back explicit notify response, not just regular notify ACK, but explicit like a different notification when you finish reading that, because typically you want the whatever you do before you send back notify ACK to be some kind of quick operation, so you don't potentially time out like blocking for some IO somewhere. So you just say, okay, I've updated something internal state saying I need to update the cache, ACK that notify, and then later, once you actually updated the cache, send a different notification back to the original guy.
Okay.
Everyone watching really. But all this stuff is all in user space right now, and the kernel doesn't even have the newer version of watch notify yet. So
okay,
that'll take some effort to actually get it all worked up in the kernel.
Okay.
All right. Does that wrap that one up then?
Yep. Thank you.
Awesome.